Okay, so today's lesson is on how to read a chemical formula. And this is important information because we're fixing to look at some chemical reactions, and we'll need to know how to read the formula for these reactions, as well as be able to set up equations that describe these chemical reactions. So, let's start with, well, what is a chemical formula? So a chemical formula is really a way to show a compound or a molecule. So it's a way to show or describe a compound or molecule. So instead of the chemist always saying sodium chloride, which we always call at home table salt, so instead of him having to say all that, he just says what? NaCl. That's your formula, right? So in essence, this is an abbreviation of the elements in the compound. Another way to look at it, it's something very similar to what you guys do. Instead of saying, all saying laugh out loud, you do LOL for laugh out loud, right? So you don't say laugh out loud, you just say LOL, or you text it. IDK. So we all know what these means, just like the chemist knows what these mean. These letters represent elements, and these elements combined represent a compound with a name. Okay, so there you go. So let's give some examples of some chemical formulas, and you guys already know a lot of them, so let's list a couple. I know you all know water, H2O for water, right? You guys know CO2 for carbon dioxide. You all know probably CO for carbon monoxide. And of course you know NaCl for table salt. I know you know of rust. That happens. Things rust when iron comes in contact with oxygen. So Fe2O3 is the formula or for rust. Or another name for rust, what the chemists would call this, is iron oxide. If you look, this is iron and this is oxygen, and together the compound, the new rust, is iron oxide. Okay, so there you go. That's what a formula is. Now, in some formulas, as you can see, there are small numbers embedded. So like here we have a 2, here we have a 2, here we have a 2 and a 3. So we're going to try and figure out what are these small numbers. So what are the small numbers in a chemical formula and what do they mean? So that's our question. What are they and what do they mean? Well, they're called subscripts. Okay, small numbers are called, subscripts. The prefix sub meaning beneath, and the writing. And as you can see, a subscript is a small number. It is beneath the actual writing. It's small and it's smaller than normal numbers would be. So let's do H2O2, which by the way is hydrogen peroxide. So all of these are our subscripts. Okay? Now, what do they mean? Totally different story. So, actually, subscripts always describe the element in front of them. Okay? Let's write that down. Subscripts always describe the element in front of them. Okay? Or before them, whichever you would like to say. So let's look at this. Let's do some examples. All right, let's do rust again, or iron oxide. So we have Fe2O3. That's our compound. So this subscript goes with my Fe, or iron, and this subscript goes with my oxygen, meaning that if I were to look at interpreting this information, I have Fe equal to 2, so I have 2 atoms of iron, and I have oxygen, 3 atoms. So if I were to draw it, what would it look like? Well, 3 oxygen, right? O, and 2 iron atoms. Okay. So we could practice with this. Let's see, let's do another one. Let's do C6, H12O6, which we all know is glucose, right? It's the sugar plants make during photosynthesis. Okay, so obviously that 6 is going to go with what? Carbon, yeah. What about the 12? Goes with hydrogen. And the the 6 goes with the oxygen. So what do we have here? What elements are present? Remember, your elements are always your letters, all right? Every capital letter starts a new element. So what elements do we have? Well, we have carbon, we have hydrogen, and we have oxygen. So how many elements total? We have a total of 3 elements here. All right, well, how many atoms of each do we have? Well, we have carbon is equal to 6. How many hydrogens do we have? We have 12. And how many oxygens do we have? 6. Well, how many total atoms are in this compound or molecule? Well, let's count them up. 6 and 6 is 12. 12 and 12 is 24. We have 24 total atoms that make up the glucose compound. All right, let's try one more. Oh, by the way, you also could describe this as what type of compound. It's organic, right? Whereas rust was inorganic. All right, good job. So let's look at one more. We are going to look at methane, Ch4, which is methane gas. That is gas that you use probably in your homes to heat your water. All right, so Ch4. So what do we have here? C does not have a subscript. So that means there's only one C present. C stands for carbon, right? H stands for hydrogen. And the 4 is going to correspond with the number of hydrogen atoms in this molecule. So carbon, how many carbons do we have? Well, there's only one here, so we have 1. How many hydrogen? 4. So what elements are there? Carbon and hydrogen, right? And how many atoms total? Well, we add them up, 5.